In this video, I'm going to try to explain why the theory leading to the prediction of black holes may be fundamentally flawed. I cannot actually prove that black holes do not exist, because something like this is non-falsifiable, but I can show in what way the basic theory has been misinterpreted over the years. I am fully aware that no one in the scientific community will want to accept my reasoning. There has been an obsession with black holes over the past 60 years, and it would take a lot to change the current paradigm, even though I'm sure it is blatantly false. I have to say that none of the observational so-called evidence for the existence of black holes is, in my opinion, unequivocal, and the highly publicized observations of gravitational wave signals from black hole mergers and EHT images could have other causes than being due to black holes. I think the current paradigm in gravitational physics would have been very different if misconceptions hadn't crept in early on when trying to understand the relationships between Newton's law of gravitation, Einstein's theory of special relativity, and Einstein's theory of general relativity. Newton published his inverse square law of gravitation in 1687. It describes the observed force of gravity between masses very well. Since it is a phenomenological theory, it does not offer a cause for this gravitational force or acceleration. In Newton's law, the space in which gravity operates is Euclidean or three-dimensionally flat, while the time is considered as an absolute quantity. Next, Einstein's theory of special relativity in 1905 describes relative motion in inertial frames of reference in which the speed of light is invariant. In 1908, Minkowski showed that this means that time can be described mathematically as a dimension additional to the three Euclidean dimensions of space. In this four-dimensional flat space called Minkowski spacetime, an element of length ds bar may be written as in equation 1. By the beginning of the 20th century, it had become apparent that Newton's law wasn't quite accurate in every situation. It showed a disparity with observation with respect to the perihelion rotation of the planet Mercury around the Sun, and not the correct amount of bending of starlight around a massive object such as the Sun. This led Einstein to his theory of general relativity in 1915, in which both space and time may be curved due to the presence of matter. In that case, the Minkowski metric above may be reformulated as we have in equation 2. This now describes space-time increments outside a point mass. A, B and C are radially dependent functions describing the curvature of time, the radial distance r, and angles theta and phi respectively. If we take an object free falling directly towards such a mass causing gravity, where the angles do not change, this simplifies to the following equation, equation 3. Using standard mathematics, often called Lagrangian formalism, one can then show that this gives for the equation of motion of the free-falling object equation 4, where A dashed equals dA by dr, B dashed equals dB by dr, T dot equals dt by dt dashed, R dot equals dr by dt dashed, and R double dot is the proper acceleration or the rate of change of free fall velocity in terms of the proper time, which is the time as indicated by a clock on the free-falling object. The next question one could ask is, how does this fit in with Newton's law? In Newton's law, as previously stated, space is defined as flat, which means that b equals 1. Substituting this into equation 4 gives equation 5, and using equation 3 we can eliminate t dot to obtain equation 6. For an object free falling from zero speed at infinity, Newton's law gives an acceleration minus gm over r squared and a velocity 2gm over r. So equating these to the proper quantities in equation 6, we then find an expression for A. A equals 1 plus alpha over r all to the minus 1, where alpha equals 2gm over c squared, equation 7. This function is shown plotted in the figure. We see that the time curvature A goes from unity or uncurved at large radial distance and becomes increasingly small as one approaches the point mass. When r is 0 at the point mass, the clock measuring time stops altogether. This is the result of using Newton's law in conjunction with Minkowski's idea that time is a dimension. It suggests that Newtonian gravity is caused entirely by the curvature of the time coordinate with respect to the radial distance from the point mass. Space is not curved at all in Newton's law. However, as mentioned, Newton's law does not describe some extreme situations accurately. This is where general relativity provides the answer. The solution of Einstein's field equations of general relativity for the gravitational field outside a point mass using the metric in equation 2 was first found by Carl Schwarzschild in 1916. Because there are three unknown quantities A, B and C, it turns out to be judicious to redefine C, the angular curvature, as C equals r bar squared, and then write equation 8. Now r bar is a new radial coordinate defined in terms of C. The well-known solution to this in terms of r bar is given by A equals 1 over B equals 1 minus alpha over r bar, as in equation 9. At this point, a fatal mathematical error is invariably made by almost everyone, and that has led to the obsession with black holes that has occurred over the past 60 or so years. Examining the function 1 minus alpha over r bar, we see that it changes sign if r bar goes below alpha, and this is taken to mean there is a so-called event horizon at a distance r bar equals alpha, behind which there is a black hole. What is never mentioned is that r bar is not identical to the radial distance r from the point mass. In my analysis above, I have already determined the function A from Newton's law, with no approximation. We thus have the following comparison in equation 10. A equals 1 plus alpha over r all to the minus 1 equals 1 minus alpha over r bar. From this it follows that r bar equals r plus alpha. Equation 11. Now we see that since r goes from 0 to infinity, r bar goes from alpha to infinity. The smallest allowed value of r bar is thus alpha, and the function 1 minus alpha over r bar never changes sign, and there is therefore no event horizon. But since we have to have B equals 1 over A to satisfy Einstein's field equations of general relativity, and we want to describe the situations where Newton's law is inaccurate, this means we have to write B equals 1 plus alpha over r. This now describes the curvature of space that deviates from Newton's law. This function also does not change sign or become irregular in any way. With B equals 1 plus alpha over r, we can now explain the situations where Newton's law does not work accurately, such as the bending of starlight and the perihelion rotation of Mercury. This spatial curvature only becomes apparent at high speeds and large gravitational fields. However, the idea of a black hole and event horizon is clearly just a mistake, since space and time are completely regular